All right, so dynamic credentials for Kubernetes with Vault and VSO. What I want to go over first before we talk too much more about that is lab prerequisites, because it is a little bit heavy if you're running this on your local machine. You're going to need Docker installed, which you're going to use to run Minikube. You'll need the Vault CLI. It doesn't matter whether you're using the Vault Community Edition CLI or Enterprise, both will work. And if, to mimic exposing services, we're going to use ngrok to make that simple and repeatable. I didn't have insight into the hotel network to do it otherwise, do it differently. And yeah, JQ and base64 is utility, so we can display some JSON, decode some secrets, and K9s for lab support if you run into any trouble. You can get to developer.hashicorp.com by either scanning the QR code or going to the link at the bottom of this slide, hashi.co/bos24-VSO, and that will take you to the page. It has links to install all of those things. So lab prerequisites, if you're doing this live. Before I get started, anyone following along on Windows laptop? Windows? Negative all Macs? Cool. So yeah, brew, install Vault, so you get the Vault CLI. We're going to run Vault Enterprise as a container just to make things easy. Docker, if you do not have it installed, go ahead and download that. With the Minikube that we're going to use to replicate the Kubernetes environment, the way the lab is written assumes that you have a clean Kubernetes environment. So if there's anything that you generally run normally on your laptop, just be aware that some command I might give you might overwrite a thing, or if I tell you to run minikube delete and you've got stuff that you're working on, that could obviously be bad, but this will make that assumption. Helms, install Vault Secrets operator. And ngrok with auth token. Again, this is just to make it easy to expose the Kubernetes API. So why are we here today? Secrets management is hard. I've had to do it in previous roles. I've walked into companies as recently as a couple years ago and found passwords embedded into Lambda functions, embedded in GitHub, and had to pull those out and clean them up and teach teams how to consume a secrets management tool, which is fine, but it also can lead to teams sort of pushing back. They may not want to change the way they're doing things today. So if you're running workloads on Kubernetes already, and teams are already managing secrets with Kubernetes secret, they may not want to refactor their application. So with Vault, you can still centrally manage all of your secrets to enable teams that are able to change. But for teams or workloads that cannot make a change, maybe immediately, you can also use a tool like Vault Secrets Operator, which is available for both Vault Enterprise, Vault Community Edition, and our managed instances of Vault, HCP Vault Dedicated and HCP Vault Secrets, to take those secrets out of Vault and create a native Kubernetes secret. So a team that's already got a workload there doesn't necessarily have to change on day one. They can work towards either refactoring their app to read from Vault directly, or you can continue to use VSO to manage and maintain those secrets. What we're going to build today, so we're going to run Vault external to the Kubernetes cluster. That will feel this will feel a bit more normal if you're using our managed service like HCP Vault Dedicated, or if you have a different team that manages Vault for you. Maybe it's not part of your Kubernetes cluster, or maybe you have separate Kubernetes clusters that that still need to benefit from Vault. So we're going to deploy the Vault secrets operator into its own namespace. And then we're going to first test using static secrets. I mean, that's just me OCD. If I'm trying something new at first, I want to eliminate as many dependencies as I can. So first thing we're going to do is just write a static secret to Vault, and we're going to see VSO create that secret in Kubernetes. Once we know that that's working, it means we have most of our config set up properly. We're going to deploy instance of Postgres and configure the database secrets engine, which if you're interested in dynamic secrets, an easy one to get started with. And then we're going to configure the Vault secrets operator to connect to Vault. Vault will then generate the secret or the role in Postgres, and Vault will write it, or VSO will write it to the Kubernetes secret. So with that, let's switch over to the demo. How's the terminal for the folks in the back? Are good? Can read it? No contrast issues? Thumbs up? All right. We didn't end up having any Windows folks, but if you have team members that do run Windows and they're interested in also learning this lab, they can take this anytime after the conference as well. There's both a Mac version and a Windows version, so they don't have to necessarily run all these USL. They can take advantage of PowerShell. So the scenario here, to maybe think through and sort of make this feel a little more real, is we have our fictitious company, HashiCorp. They make this really awesome coffee. For any folks who are local to Massachusetts like me, they might be a competitor to a certain 2-letter coffee company. I guess 1 letter now. And to compete with them, they went out and acquired international brewing machines. So they have to, IBM doesn't have a great secrets management workflow. So they have to work together to get the IBM application onboarded to meet HashiCorp security standards. Currently, IBM is just, merely provisioning roles in their database secrets engine. They put those in a Kubernetes secret, so now they're basically sitting there unmanaged. So we're going to see how they can replace that with the Vault secrets operator and Vault. There's some, most of the text up here, solution and talking about the Vault secrets operator we covered earlier, but again, for anyone who wants to read up on this after the conference, or you have teammates that want to come and work through this, they have some of that background here. So the first thing we're going to do is set up our lab. Oh, I forgot to mention, if you don't want to install all these things on your laptop, we do have a interactive version of this built into the page. So if you click on launch or start interactive tutorial, this is, you can do it all in the web browser. It's not a step-for-step match to this lab just because of some limitations we had around getting it working in that virtual environment, but you can still set up Postgres and Minikube and VSO and see how dynamic secrets work. So with that, see how often I miss the actual command key because I don't have a proper Mac keyboard at home, so I keep missing Option and Command up. So this temp directory is really just to hold files while we do this lab. You don't have to necessarily do this in production. And we're going to start Minikube. If you haven't run this before, it might take a few minutes while it downloads the image. Hopefully y'all were able to do it before we got started or have it locally already. While that's going, I'm going to keep an eye on Minikube over in the background. But for those that have Minikube started, we can at least walk through the rest of the lab and what's going on. Yeah, look at that. That's way faster. That's what I expected. Thank you. All right. When in doubt, reboot. All right, so I've got Minikube up and running, finally. So the next thing we're going to do is basically just mimic exposing the Kubernetes API. So depending on your environment, depending where you're running Kubernetes, you may be able to do this with services like AKS or EKS where those are already exposed. But since Minikube is just a local development environment, we need to do that. So I'm just going to run proxy here in one tab, not that one, that one. And then I'm going to start ngrok, which maybe you're using already as an ingress controller or a load balancer. Maybe you're not. But it was the easiest way to replicate this for everyone here. I'm going to store a lot of stuff as environment variables. Again, that's not a requirement if you're doing this in production. It's just for ease of following along in the lab so we can pass different parameters when we're configuring Vault or Kubernetes to connect to Vault. So I'm going to get this, I'm going to set this to my Kubernetes address. Yours is going to be unique to you if you've started this up on your laptop. I suppose you could use the one that I'm putting in here if you type fast enough and you can see good enough. Is the screen resolution still big enough now that I've restarted in the back? Good? Bump it up. Okay, so I've got the address for my Kubernetes API now. The reason that we care about that is because we're going to use the Kubernetes auth method for Vault, and Vault is going to use the Kubernetes API to validate that the requests coming from that cluster are trusted. So that's why we're going to need that. We're going to need that address in a moment when we configure the auth method. Next thing we're going to do is start Vault. The sections at the end do require Vault Enterprise to do instant updates. So if you grab that serial number, and then we can start a Vault Enterprise container. If you're doing this, this will be updated after the conference to do Vault Enterprise if you have your own serial number or Community Edition. If you wanted to try this with Community Edition now, basically just delete the Vault license environment variable and change the container image to just HashiCorp Vault, and that'll start a Community Edition container. And just make sure that everything's playing nice now. There's my Vault Enterprise container up and running. We're going to use the normal Vault supported environment variable so we can connect to that and get our Vault configuration set up. Make sure Vault's running and unlocked. Or unsealed, there we go, unsealed. And just to make sure, there is our only enabled auth method right now. So that's the token auth method that's enabled when you fire up Vault. Now we're going to install the Vault Secrets operator. I'm going to skip the Helm update, maybe? Yeah, I'm going to skip that because my laptop has been unhappy. So that's been deployed. So if you look at the command there, we're telling Helm to also, when it's deploying this, to create the Vault Secrets operator controller in its own namespace, which is why we have that create namespace parameter at the bottom there. And that has been deployed. In addition to installing the controller, it's also adding the custom resource definition to your Kubernetes environment. So when we create resources like Vault Auth and static secrets, if you tried to do that before installing Vault Secrets operator, those things would not work because your Kubernetes cluster would not be aware of them. The next thing we're going to do here is create a namespace to store Vault-specific resources for Kubernetes to connect to. I read every piece of Kubernetes namespace documentation I could find, and the recommendation was use namespaces, but don't use namespaces, so I erred on using namespaces because I like to keep things nice and neat. In this case, we're going to connect. We need to now get the address for the Vault cluster. So Kubernetes knows how to get to Vault. So in a production environment, this is just going to be the address of your Vault cluster. In my case, since I'm starting everything up on the fly, I'm going to go grab that and, again, write that out to an environment variable. And now I'm going to create a Vault connection resource. So if you look towards the bottom 3 lines up, we're going to take that address from our Kubernetes cluster or your Minikube environment, and that's what we're going to use the address to make sure Kubernetes can get to Vault. And now that that connection is created, just to make sure it got everything properly, we're going to test that, and you should have a Vault connection accepted message when you run the describe on that connection. So now that Kubernetes can get to Vault, we're going to start setting up the stuff to enable the Kubernetes auth method. So right now, for that, we're going to need a service account. I'm going to create that in that Vault namespace I created. Again, that's my own OCD, wanting to put everything in their own tidy little spots. You could certainly drop everything in default, I suppose, if you wanted to. Although they say don't do that as well. Unless you need to do that, then do it. This has the service account and a service account token. So we're going to use that to configure the Vault auth method. And I'm going to create a role that also permits this service account to access the API. These commands here, again, we're just grabbing, we're going to grab the token and cert so that we can feed those into Vault. And since they're base 64 encoded strings, just going to go ahead and decode them and make sure they look okay, which they do. So there's the cert, and now we need the token for the service account. So now you have everything you need to enable the Kubernetes auth method. So I stashed, we have the URL for Kubernetes, which is the ngrok address when we started the lab, the token, and the cert we just created. What did I miss? I didn't enable the auth method. That's what I missed. Got all excited about configuring it and forgot to enable it. So now that it's enabled, there we go. So now we've written our Vault configuration. So now Vault can reach out to Kubernetes and verify that workloads or pods they're requesting access to Vault are in fact trusted. I mentioned before when I set things up, I clearly don't like to plan in advance and start services beforehand, but I want to test just a simple static secret. So that's just going to be a key value pair secret. And I'm going to write a pretty simple username and password. If anyone gets the reference, I will take you out for coffee afterwards. So we have a static secret now created in Vault. Now for VSO to be able to get there, we're going to need to feed it a role that has permission to that KV secrets engine. So before I could do that, I'm going to create a policy that allows the Vault role to read from this path. So when we enabled the static secret engine, the mount that we gave it was static, and the path is example creds or example app creds. So that's why I've got this path here in my policy. Policy created. Sweet. Now we're going to create a role. This role is going to have that policy we just created attached, and then later we're going to feed this role to the Vault static secret resource. So VSO will basically read this role, and it will get back the KV read policy. And also check out the bound service account names and bound service account namespaces. If I had set these things, with this role, if I had set any of my VSO configuration in a different namespace or with a different service account, it would not be able to read this role. So you want these to match your environment outside of this lab environment to your Kubernetes namespace and your Kubernetes service account name that you created. And now let's, so now I'm going to create the namespace that I got here, so static example app. Did that just so it's clear when we're doing static secrets versus dynamic secrets. Going to create a service account now in that static example app namespace. So this service account is what's going to actually create the secret in Kubernetes. This is different than the service account that you're using for the Kubernetes auth method. This has access to all the things in this particular namespace. And now we are going to configure Vault authentication. So using the service account we created in the static example app namespace, we're using the Kubernetes auth method here as an example. The mount kept as the default, so for the folks that raise their hand that are newer-ish to Vault, when you enable a thing like an auth method or a secrets engine in Vault, it's going to take the name of the thing you're enabling as the default path. If you change that in your environment to be team-based or whatever, you'd want to update this mount here to match the auth method. And again, we're allowing just this static example app namespace that we just created. Now that VSO can authenticate with Vault, now we're going to actually create that static secret. So we're going to create it again in that namespace. Similar to the Vault auth, your mount and your path is going to be important here. So when we enabled the KV secrets engine, I did it at the mount static. Then we wrote our policy. It also pointed to that mount, and then again the example app creds where we wrote the Jeff Albertson worst password ever KV secret. Last call on getting that reference. Am I clear on buying people coffee? No Simpsons fans here, huh? I thought maybe worst password ever would have given it away. All right, so now that is created. So now if I go look at my static example app namespace and read that secret, I should see this VSO static creds from Vault, which is the name that we defined in the static secret resource. Let's hope that worked. Here we go. Now we have a Vault managed secret, in this case from the KV secrets engine, created as a Kubernetes secret. So the Vault secrets operator took the Vault auth that we created, took the Vault static secret resource we created, reached out to Vault, and using the Vault policy and the Vault role we created when we configured the Kubernetes auth method, it was able to read that secret and then create it in Kubernetes. Just to make sure it matches, let's read back that secret. And worst password ever. Jeff Albertson is comic book guy's name for Simpsons fans out there. So if you were a Simpsons fan back in the day, that's comic book guy's real name. So I can see my secrets. Now I want to test that app. So we've got that International Brewing Machines app that we need to test. So I'm going to create a deployment for that. So if you notice here, I haven't filled in the bottom portion yet, the DB host and the database name. We don't have Postgres deployed yet. That's fine. We're going to do that in a bit. But basically, what I've got defined in this deployment is that I want to get this DB user and DB password. I'm going to get that from a Kubernetes secret that matches the one we created with the key username and password. Deploy that. and hopefully not have it take 15 minutes to pull that image. This app is just, it's basically got two endpoints in it. So there is an endpoint called secret, which is just going to display the secrets that we fed the app. Hopefully you don't run that kind of endpoint on your workloads. And then we've got one called status, which is when we get to the database secrets engine portion, we'll actually take the credentials, make sure that Vault created the Postgres role, connect to the Postgres database using that role and password. So there it's running. And now if I go hit that endpoint, I should see, hopefully, Jeff Albertson and worst password ever. So we know VSO is working. We know Kubernetes and Vault can talk. We know the Vault Kubernetes auth method is working. VSO is able to take the Vault connection that we created with the service account and service account token and connect to Vault, and everything is working there. So from here, I'm not going to finish that statement. I was going to say something that would jinx myself, so I'm not going to do that. Just because my local laptop seems a little resource constrained right now, I'm just going to delete that pod. And so now we're on to dynamic secrets. So this is where things get cool, because instead of manually provisioning roles for different services I need to connect to, you can use, in this case, Postgres, the Vault database secrets engine, which is going to provision Postgres roles for you when they're requested. I was talking with somebody earlier at the education booth, and they mentioned, they kind of started in their environment and they have, passwords and usernames embedded into scripts and things like that in source code. It's obviously something we don't want. If you had, if you happen to have one of these dynamic credentials leaked, whether it's committing it directly in source code or elsewhere, the cool thing is that eventually this is going to go away. So you're really limiting your exposure of these credentials versus a username and password that just exists out there forever, doesn't change, isn't rotated often. Once somebody gets a hold of that, they can wait till you go home for the night and maybe you're not checking your phone because you turned off alerts like I used to do when I was on call after getting alert fatigue for a couple days. So we're going to start a Postgres container to do this with. And let's make sure that's running. Where'd you go, Docker? There's my Postgres container. Similarly, going to get the address for Postgres from my Kubernetes environment, or from Minikube. Again, it's just like Vault, this would be the address of your Postgres database. And now we're going to enable the database secrets engine. So notice here we're just enabling it, secrets enable database. So that's going to be our mount later on, similar to when we did the static secret and we had to define our Vault static secret mount as static. When we get to creating the Vault dynamic secret resource, want to make sure that the mount matches that. Database secrets engine enabled. And now we'll give it the credentials that I set when I started the container. So Vault can now connect to that Postgres server, and now we need to give it a role that tells Vault how to create credentials. So this is a pretty stock one, but in your environment it might be different. Also a good practice in production to make sure that you don't end up with any orphan credentials is to also do a custom revocation statement so that when that credential expires, Vault properly knows how to get rid of it. It has some defaults built in. Those don't always work in your environment, so also pass that in. And now I just want to make sure that that's all working, so I'm going to read that role. and I should get a username and password. So this username and password, Vault created it by connecting to Postgres with the creation statement I gave the role and created these credentials. So whatever database your workloads need access to, as long as Vault knows how to create usernames and passwords to access that, you should be in good shape now. I'm going to create, just like we did for the static secrets, I'm going to need a role for VSO to read, and I'm going to need to attach a policy that's going to permit it to connect to the database secrets engine. So again, path is important here. So created that secrets engine at the mount database. There's my policy. And now going to configure the role. Like I did before, I'm going to limit the bound service account and bound Kubernetes namespaces so that it's not shared across multiple namespaces, potentially multiple teams, multiple environments. And I've attached the database read policy. So when VSO goes to read that, the only thing it's going to be able to do is what we've defined in the policy. Create my namespace in Kubernetes. This stuff should all feel similar. It's similar to setting up the static secret. I'm going to create my namespace here, which again matches that Vault role we created earlier with the bound service account name and bound service account namespaces. So I've got the service account created. And now going to configure authentication for VSO. This is almost the same as the static secret ones. Again, this is for VSO to authenticate. So we've got the Kubernetes auth method here, and we're allowing, in this case, the dynamic example app namespace for this specific service account that we just created. And now we're going to create the dynamic secret. The name here is what the Kubernetes secret will be named. We're looking at our database mount, which is where we enable the database secrets engine, and looking at the Vault role dynamic example app. Rolling restart targets, just want to call that out here. You don't necessarily use it in the lab, but wanted to highlight it. So if you have workloads that can't on the fly refresh credentials, this will have VSO go out and restart any workloads that you might have that need to get those new credentials if they can't do that on the fly. You could potentially leave that out if that use case doesn't apply to you. Now I want to keep my fingers crossed and make sure I have VSO dynamic creds from Vault. So like the static secret, VSO is now reaching out to Vault. I didn't have to create this secret manually. It's not, in this case, a long-lived secret. It's not just a username and password that will exist until I go and change it. It's going, Vault's going to manage the life cycle of those credentials. Make sure those look right before I go out and test. And that looks roughly right. My Kubernetes auth method is part of the username here. You can still use username templates and things like that for those that are familiar with Vault. And I have a password. So now I want to go and make sure that the app can read those and connect to my database. So down here, you'll notice I've got the K8s to Postgres address for my database. So this is what this particular pod is going to use to go out and connect to that Postgres container we started. In this case, I'm just connecting to the default Postgres database on the default port, so you update those for your specific needs. And now we'll deploy that. And wait for this part. This should start up pretty quickly since it's already been downloaded. It's the same image we used before, already running. Thank you, demo gods, for being kind to me at the end of this. And now I'm going to go hit that secret endpoint like we did for the static secret, just to make sure that my values are being read. So there's that username and password we got a couple steps ago. And now to make sure that I can actually connect to the database, I'm going to hit the status endpoint and should get a success message back. So there we go. This particular pod now can connect to, in this case, Postgres, and whatever I need to do from there that the role has access to is all set up. Any questions before we move on here? All right, so we've got about 20 minutes left, so the bonus section's at the end. Setting up a client cache, so this is helpful or recommended when you're using Vault Secrets Operator. So if you have to do a deployment or redeploy, you don't want the things that VSO is managing to become orphaned. So we're going to set up this client cache. It's not done by default because we're going to use the transit secrets engine from Vault to encrypt those. So this requires a few extra steps to set up. So I'm going to enable the transit secrets engine and create an encryption key. Again, for the folks that raise their hand in Vault, we're going to need a policy to permit access to that particular secrets engine, since we don't want to just let anyone access that. So I'm going to create a policy and create a role that will be used by VSO to make sure it can encrypt that cache. So you could do this all in advance too. I broke it up because I didn't know how long the lab was going to take. In this case, since I've already deployed VSO and I didn't do this initially, I need to update my VSO deployment to enable the, so notice here we're looking at the transit secrets engine. We're enabling the persistent cache, the client cache here. Now we'll upgrade VSO or update VSO. So while it's updating, it's probably going to take a few seconds to show up here. I probably don't have anything yet. It's going to create the, in this case, it's going to create that cache in the same namespace you deployed the Vault Secrets operator in. So in this case, we're looking at the Vault Secrets operator namespace, which is the one we specified when we deployed the Vault Secrets operator. And there are our caches. So we have, in this case, we have two because we've got the static secret we enabled initially to make sure that we had all of like our Vault, our Kubernetes auth method working, and then one for the dynamic secret. Everything up until this point, if you want to go back and do this later on, all of this, the stuff we just did so far will work with Vault Community Edition. So if you don't have Vault Enterprise or HCP Vault Dedicated, you can do all these things. You could just download the Community Edition. You could run it in dev mode. You could run it as a container, whatever works for you. All of that stuff, the dynamic secrets, VSO, that will all work without Enterprise. The instant updates, this piece does require Vault Enterprise because it's based on the new event features that were added in Vault 1.16. So since I want to give access to something else in Vault, guess what I have to do? I have to create a policy. So this policy is giving read access to events. So if you tried to do this with Vault Community Edition, this would eventually not work because that doesn't exist. And then going to update, right now it supports static secrets, so the one we tested initially. Got a warning here because of how I deployed Vault, so you can ignore that for the purposes of this lab. And I should now see in my Vault Secrets operator namespace, started watching events. So that's the event watcher. It's going to use the Vault Enterprise events feature to monitor for those. So now I'm going to update from the worst password ever to the best password ever. And I should have those available in Kubernetes now. Best password ever. All right, so this lab, we deployed the Vault Secrets operator in Kubernetes, configured the Kubernetes Vault auth method to connect to our Kubernetes API, make sure that the Vault Secrets operator is in fact a trusted source. So that's how it's authenticating and connecting to Vault. We created a couple roles, one for the static secret namespace, one for the dynamic secret namespace, and had policies that permitted VSO to read those, or in the case of the database secrets engine, connect to Vault and have Vault create those credentials. So with that, that's a wrap.